So in the last section, we learned about concavity and increasing and decreasing, and then we moved on to L'Hopital's rule. But let's go back to graphs. So what happens when a graph is increasing, decreasing, concave up, concave down? So this section is how to sketch a curve, or how to sketch a graph. So by looking at the first and second derivatives, can we actually sketch the original graph? That's what this section is about. So to sketch a curve, what we're going to look at is we're going to look at x-intercepts, if they're relatively easy to find. So if they're easy, the question will always tell you if we should look at x-intercepts or not. We're going to find the y-intercepts. We're going to find intervals of increasing and decreasing. We're going to find intervals of concavity. Concavity. We're going to find end behavior. And we're going to find asymptotes. I'll put kind of a star beside that, because not always. Sometimes there won't be any asymptotes, so we won't necessarily look at that, but we're going to find asymptotes along with the end behavior. So let's go through these. The x-intercept, how do you find the x-intercepts? We set the function equal to 0 and solve for x. What is the y-intercept? That's where we plug in 0 for x. So if you want the x-intercept, set the y value equal to 0. For the y-intercept, set the x value equal to 0. Intervals of increasing, decreasing, that's the first derivative. Intervals of concavity, that's the second derivative. End behavior, that's two limits. I look at the limit as x approaches infinity of my function, and I look at the limit as x approaches negative infinity of my function. So I look at both of those limits. Asymptotes, that's a little bit different. Asymptotes is where f of x is undefined, and one of the limits, either the right or the left, is plus or minus infinity. So again, asymptotes, sometimes we won't be looking for them. It's more if it's obvious, so we'll see some. So a little bit of notation, what we're going to do is that in curve sketching, there's kind of two shapes to curves. I either have kind of a bowl shape or an upside down one. So on this one, and I'm always going to put f prime first and then f double prime. So on this one, the slope is negative, but it's concave up. So I'm going to put negative plus. This one, it's a positive slope and still concave up, so that's plus plus. Over here, I have positive slope, but it's concave down. And then here I have negative slope and concave down. That's going to be the notation that we use to kind of get the shapes of these graphs. So we want to understand this notation. The first sign is telling me the slope, which is f prime. Second sign is telling me concavity, which is f double prime. Alright, so let's see how this works. So example 1. Let's sketch the curve x cubed minus 2x squared plus x. So what I'm going to do first is I'm going to find the x-intercepts. So to find the x-intercepts, I want to set the entire function equal to 0 and solve for x. So to solve this for x, I'm going to factor it. So let's see, this will be x squared minus 2x plus 1, which is x minus 1 squared, which tells me that x is 0 or x is 1. So my two x-intercepts are going to be 0, 0, and 1, 0. The y value is always 0 for your x-intercepts. Next, my y-intercept. So this one is a lot easier to find. All I do is plug in 0. So if I plug in 0, I get 0. So my only y-intercept is going to be 0, 0. The x value is always 0 for your y-intercept. Third thing I'm going to find, increasing, decreasing. So to find increasing, decreasing, remember this is our number line for f prime. So let's take the derivative. So I'll get 3x squared minus 4x plus 1. Which we can actually factor this. This factors, since I'm setting it equal to 0, as 3x minus 1, x minus 1. And now if I solve this for x, I'll get x is 1/3 or x is 1. So I'll come up here to my curve, or my line, and draw those 2 points. And now let's start testing points. So something to the left of 1/3 may be 0. F prime of 0 is positive. Now something between 1/3 and 1 may be 1/2. So let's see, if I plug in 1/2, I'm going to get 3 times 1/2 squared minus 4 times 1/2 plus 1, which is going to give me something that's negative. So if you plug in 1/2, you're going to get something that's negative. And then lastly, plug in something greater than 1. How about 2? So 3 times 2 squared, that would be 4, so 12, minus 8 plus 1 is definitely positive. So there are my intervals of increasing, decreasing. Next, I'm going to look at concavity. So concavity is the second derivative. So that's going to be 6x minus 4. Set that equal to 0, and I get x is 2/3. So there's my second derivative line. Now I test something to the left of it, so I'll test 0. 6 times 0 is 0, minus 4 gives me something negative. And then something larger than it, how about 1? 6 times 1 is 6, minus 4 is positive. Okay, so I've done increasing, decreasing, and done concavity. Next was end behavior. So 2 limits I'm going to look at. I'm going to look at the limit as x approaches infinity of my function. So the function here was x cubed minus 2x squared plus x. So go back to our limits about polynomials. Whenever I had just a polynomial as x approached infinity, this was infinity. And now I look for negative infinity. Here the power is odd, so this is going to approach negative infinity. And since this function is always defined, there aren't going to be any asymptotes, so we're not going to actually bother with looking for those. Alright, so I think at this point we have enough information to plot or to sketch our curve. So when you're sketching your curve, what you want to do is first plot all of your critical values and all of your possibly inflection points. So those are called transition points. So we're going to plot all of our transition points. The transition points are any point that you've explicitly written on either one of these lines. So our 3 points are 1/3, 1, and 2/3. So I'm going to come up here and I'm going to plot 1/3, 2/3, and 1. And then I'm going to put a dotted line. Hopefully you can see that. Okay. Now, I'm going to go back to what we originally wrote. Remember that, this thing? So this was slope negative, concave up. This was slope positive, concave up. This was slope positive, concave down. And this was slope negative, concave down. I'm going to use all of those to write something at the top of each one of these little regions. So when I wrote in these three lines, I kind of split my region up into 1, 2, 3, 4 regions. So look at anything less than 1/3. Anything less than 1/3, what's the slope? So what's f prime? It's positive. Okay. Anything less than 1/3, what is the concavity? Negative. Okay. So that's for this entire region, all the way up to that dotted line. Next, between 1/3 and 2/3, what's the slope? So look here, between 1/3 and 2/3, 2/3 is in the middle there, it's going to be negative. I could also say this one's going to be negative, might as well write that in. Between 1/3 and 2/3, what's my concavity? From this graph, that would be negative. And then to the right of 2/3, the concavity changed to positive. Concavity still positive to the right of 1, but the slope went to increasing. So I have all of that. So let's write down what this means. So plus minus was this shape. Minus minus was this shape. Negative plus was this shape. And plus plus was that shape. So now I have all my shapes. Next thing I'm going to do is I'm going to plot my x-intercept and my y-intercept. So what did we get for those? We got that our x-intercepts were 0, 0 and 1, 0. And my y-intercept was 0, 0. So those are the only points that I have. And then we don't have any horizontal asymptotes because the end behavior went off towards infinity and negative infinity. So this is all the information that I have. So now let's sketch it. So I have to go through this point, and it says that anything to the left of this line has to look like this shape. So probably something like this. Remember, these are just rough sketches. Okay, next, I know that I have to have this shape. Whoops, messed that one up. So I did that shape between 1/3 and 2/3. Then between 2/3 and 1, I have to have this shape, but I have to go through this point. So there's that. And then lastly, from here on out, I have to have that general shape. So there's my curve sketched. All I did was just kind of put these shapes in between the dotted lines, and that's what we got. Let's do another one, and I think it'll be probably a little bit easier this time. So example 2. Let's sketch f of x is 2x minus 4 over x minus 5. I'm going to go through the same process. First thing is find my x-intercept, or x-intercepts if there's more than one. So remember, for x-intercepts, you set the whole function equal to 0. Well, if a fraction is equal to 0, that means the numerator is equal to 0. So x is equal to 2. So my only x-intercept is 2, 0. Remember that the y value here is always going to be 0 for the x-intercept. Okay, next was my y-intercept. So for the y-intercept, I look at f of 0. So if I plug in 0, I'll get 2 times 0 minus 4 over 0 minus 5, which is 4/5. So my y-intercept is going to be 0, 4/5. The x value is always 0 at your y-intercept. Okay, now I need to look at intervals of increasing, decreasing. So that's the first derivative. So my function was 2x minus 4 over x minus 5. To find the derivative, I got to use the quotient rule. So this is my u, here's my v. So u prime v minus u, v prime is just 1 over v squared. And let's simplify this just a little bit. 2x minus 10 minus 2x plus 4 over x minus 5 squared. Well, my 2x is going to disappear, so I get negative 6 over x minus 5 squared. And now let's find my critical values. So remember, critical values are, where is this 0? Well, this is never 0, so I'm not going to get any critical values for that. But also, where is it undefined? Well, it's undefined at x equals 5. So let's draw my number line, maybe up here. So undefined at 5. Now let's look to see a value to the left. So if I plug in maybe 0 to my derivative, which was here, where this was my derivative after I simplified it, I get negative. And now I could plug in something to the left, so maybe 6. Plug it in, I also get something negative. So there's f prime. Now let's look at concavity. So for that I need the second derivative. So remember that the first derivative we simplified to be negative 6 times x minus 5 to the negative 2. I'm just going to rewrite it slightly. So to take the second derivative, I'm going to use the chain rule and get 12 times x minus 5 to the negative 3 times 1, but I'm not going to write the times 1. So this is 12 over x minus 5 cubed. Assuming that we did that right here. Now let's plug in some numbers. Or sorry, let's see, is this ever 0? No, it's never 0, just like the first derivative wasn't. But is it ever undefined? Yes, at x equals 5. Okay, plug in something less than 5, so how about 0? If I plug in 0, I'm going to get 12 over negative 5 cubed, which is definitely negative. And now let's plug in something to the left of 5, so maybe 6. So 12 over 1 cubed is positive. So there's my concavity. Next thing I'm going to look at is horizontal asymptotes or long-term behavior. So for that I got two limits. Got to look towards infinity, and I got to look towards negative infinity. My function was 2x minus 4 over x minus 5. 2x minus 4 over x minus 5. So let's start with this first one. Remember when we were trying to do limits, we would take out the coefficients. So the coefficient here is 2 and 1, and just leave our highest powered terms. So this is 2 times the limit as x approaches infinity of 1, which is 2 times 1, so 2. Down here, same thing. Bring out your coefficients. Oops, limit. And then leave your highest powered term. Same thing as we got above, so 2. So our horizontal asymptote is y equals 2. That's our long-term behavior. This one, we are going to have asymptotes. Where are we going to have an asymptote? Well, I'm going to have an asymptote at x equals 5 because my original function was not defined there. If I look at the limit as x approaches 5 from the left, well, as x approaches 5 from the left, that means that the numerator is getting smaller but in a negative direction. So this is negative infinity. And then if I look at the limit as x approaches 5 from the right, I'm going to get positive infinity because it'll be a positive number over a positive number. So at this point, we've done everything. We're ready to graph. Before I graph, let me kind of put our signs here. So remember, this is concave up, so the second one is positive. This is concave down, so the second one's negative. Negative slope, positive slope, positive slope, negative slope. So there are our signs. So go back to your two number lines. Let's bring those back. My two number lines, I only plotted the same point. So 5. So that's the only one I'm going to draw. So there's 5. Then I draw a dotted line there. Now in addition to the asymptote, or the transition point at 5, I'm also going to plot the asymptote, or the horizontal asymptote. So that was 2. So I plotted my horizontal asymptote, I plotted my transition points. Now let's look at the signs. To the left of 5, what was the slope? It was negative. And to the right of 5, the slope was also negative. To the left of 5, what was the concavity? It was negative, and to the right was positive. So now I have my signs. Negative, negative corresponds to this shape. Negative, positive is this shape. I'll put it right here so we can see it. Now let's plot our points. So I'm going to plot my x-intercept. My x-intercept here was 2, 0. And my y-intercept was 0, 4/5. Now we can plot this. So I know that it has to go through these 2 points and it has to have this general shape. Also it goes towards negative infinity here because I have an asymptote. And since the horizontal asymptote is this line, I have to approach that. So let's see if I can get this. So there's the curve to the left of 5. Now over here I have this general shape. Now the question is, does it lie above this horizontal line or below? Well, our only x-intercept was 2, 0, so it can't lie below. So it has to be above like that. So there's the sketch of my curve. So again, go through those 5 things. Asymptotes are not as important. The horizontal one definitely is, but not the vertical one. So go through those 5, write out your signs. That'll give you how to sketch the curve.